Alright, in this video we're going to start talking about density. We're going to do a couple labs over density. And the first thing we're going to talk about is what is density. So density gives us a way to compare the mass of an object to the amount of volume it occupies. And so for instance, if items are denser than water, they are going to sink. So like if I put a piece of metal in water, we are going to assume it's going to sink to the bottom. If you drop a rock in water, it's going to sink to the bottom. This is because these items are more dense than water and allows it to sink to the bottom. Items that are less dense than water are going to float, such as your ice. This is why ice floats in water, is because it's not as dense. Now, the denser something is, the more items that are shoved into the same amount of volume. So in order to solve for density, we need an equation. So to find density, you're going to take your mass, you're going to divide it by your volume. And we can get a few different units. We can have grams per milliliter. This is usually when we have liquids. Or we can have grams per centimeter cube. This is usually when we have solids, because volume for liquids is milliliters, volume for solids is centimeter cube. So this is relatively easy. It's just a really quick math computation. So if we have osmium, which is a dense metal, we're going to try to figure out its density. If we have 50 grams of this is a solid because we can see that it's in centimeter cube, so we have a cube of osmium. And we're going to try to find the density. So density is equal to your mass divided by your volume. Our mass is 50. Our volume is 2.22. So if we take 50, we divide it by 2.22, we get an answer of 22.5225225, so on and so forth. The calculator is giving me lots and lots of digits. This guy has 3. This guy has 3. When we're dividing, we have to go by the least number. Since they each have 3, that means I get to keep 3, so I'm only going to keep 1 decimal place. So 22.5 grams per centimeter cubed. Okay, so when we are dealing with volume, when we're dealing with density, there are several different ways we can get to volume. So like I was saying in the last slide, when we have solids, we usually use cubic measurements such as centimeters cubed. This is when we have a cube or a rectangle or a square and we can physically measure the length times the width times the height, and we can get our centimeters cubed. We can also do liquid measurements where we use a graduated cylinder, which is what you guys see to the right, which we talked about in previous videos. This is where we can measure a liquid in millimeters. We just simply place the liquid in a graduated cylinder. However, not all things are nice and easy to measure like that, and so we have something called an irregular solid. And what we do to measure the volume of an irregular solid, this is something that maybe is very hard to measure because it's an awkward shape, or maybe there's dents taken out of it, it's been dropped a few times, or maybe it has a random shape coming out of the top of it. Like some of the weights that we're going to use in the lab, we're going to have hooks coming out of the top of it, so it's not something that you can really easily measure length times width times height. So what we can also do is you can figure out volume by displacement. And so what we do is we can actually fill a graduated cylinder with a certain amount of water. This one has 35.5 millimeters in it. And then we can drop our irregular solid into the graduated cylinder, and then when we do that, it's going to cause the volume to rise. And then we can take the new measurement, so it started out at 35.5, it rose to 45, and this allows us to figure out what the volume is when we subtract it. So if you subtract 45 minus 35.5, you're going to get a rise of 9.5 milliliters, which means that this object that you placed in there occupies 9.5 milliliters, and we would then be able to do this in a calculation. Now, when we are doing density, we just need to basically practice. So in this problem it says, what is the density of a 48 gram sample of a metal if the level of the water in a graduated cylinder rises from 25 to 33 after the metal is added? So this would be an irregular solid like we saw in the one before. In our graduated cylinder, we started off at 25. The water rose to 33, which would give us a displacement of 8 milliliters. So the volume is going to be 8 milliliters. So if we now do our math, so we're going to do our density, which is equal to our mass divided by our volume. Our mass is 48 grams. Our volume is 8 milliliters. When we're dividing, we have to look at the number of sig figs. This answer has 3. This one has 3. This one has 3. So when I put this in my calculator, I get to keep 3. No matter how accurate the calculator tells me, I can only keep 3. So if we do 48 divided by 8, the calculator spits out 6. Is 6 as accurate as 48.0, as 25.0, as 33.0? No, 6 is not as accurate. So we have to add 2 zeros in order to convey the amount of accuracy to the person reading your data. Now, I know it sounds silly to add those 2 zeros just to, most of you guys don't understand, but 6 is completely different from 6.0. So let me explain the difference. So if I tell you 6, that means our answer has been rounded, and our answer is anywhere between 5.5 and 6.5. So we have a range of 1. When I say 6.0, that means that my range is anywhere from 5.95 to 6.05. Much smaller range, correct? And then if we do this again, if we say 6.00, that allows my range to be even smaller, so we could go 5.995 to 6.005. So even though adding those 2 zeros looks like a silly thing to do, it does drastically lower our error. And so we can all see that this is a much smaller range than this. This is a range of 1, whereas the answer has a range of a thousandths place. Alright, so let's do another example. So we have 3 liquids, and we're going to pour them into the same jar. And I want you guys to tell me what the layers would be. So here's our jar. Remember, the denser items are going to go to the bottom, the lighter items are going to go to the top. So we have 3 liquids, we're going to pour them all into a container, and we're going to allow them to separate, and we're going to see which one's going to be in the bottom. This is like oil and water. If you guys shake up oil and water and you let it sit for a while, the oil will start to float on top of the water because oil is less dense than the water. So we look at our densities. Our heaviest one is the Cairo syrup, so it's going to go on the bottom, followed by our water because it's at a 1, and then on top we're going to have our oil. So we're going to have Cairo syrup, water, and then oil based on the densities that were provided. Now, the last one is a difficult one, but we're going to bring in that whole idea of a conversion factor like I was telling you before, because like I said, conversion factors are necessary when we're not comparing two things that are as easy as just moving the decimal like we can see here. So we can take 0.702 grams and turn it into a conversion factor. So what we're going to do, remember how I said when you're doing a conversion, you always start with what they're asking you to convert. They're asking us to convert 875 milliliters, and they're asking us to convert it to kilograms. So here is our conversion factor. Milliliters is already on the bottom, so all we have to do is place it here. Okay, that got rid of our milliliters. Now we're in grams. Now the problem's asking us for kilograms. If you go back to your prefixes, you will see that kilo is 1,000 times bigger than a gram. So that means that there is 1,000 grams in 1 kilogram. Our grams now cancel out, and now we just have to do the math. So in your calculator, if you do 857 times 0.702 and then divide it by 1,000, you get an answer of 0.602. And the reason I kept 3 digits here is because 875 has 3 significant figures, and then of course I need a unit of kilograms.